Now let's see the B part of the question. Cosec square 57 minus 10 square 33 plus cos 44 into cosec 46 minus root 2 cos 45 1060. Cos 45 1060 are a standard value. They can be taken otherwise also. But these values 44, 46 will add up to be 90. So these are complementary, and 57 and 33 will add up to be 90. So they are complementary. So we can change them into each other, like cosec square 57 minus 10 square, what can I write? 10 square, I can write it as 90 minus 57. 90 minus 57 will give me 33. Similarly, cos 44, I can write cos 90 minus 46, and this is cosec 46 minus root 2. Cos 45 is 1 upon root 2. We know the value of cos 45 is 1 upon root 2. And 1060 is root 3. So 1060 root 3 whole square. The value of 1060 is root 3, so root 3 whole square. Now let us see the values. Cosec 57, 1090 minus theta will become cot theta. It will become cot theta. Cosec square 57 minus cot square 57 plus cos 90 minus theta will be sin theta. It will be sin 46. It will be sin 46. Cosec 46 minus, this will cancel, 1 minus 3. This is minus 1 minus 3. Okay, minus signs are there. Now cosec square theta minus cot square theta is 1. Cosec square 57 minus cot square 57. We know the basic identity. Cosec square theta minus cot square theta is 1, so it will be 1. Sin 46 and cosec 46 can be written as 1 upon sin 46 plus minus 4. So it will cancel. It will be 1 plus 1 minus 4. That will be minus 2. So what we have done is we tried to use the complementary angle relations. We tried and used complementary complementary angle relations. Like we could realize, whenever you have been given questions like this, what you should look for is that are these complementary angles somehow? Can we correlate them with the help of complementary angle relations? If they are complementary, then certainly there will be some kind of complementary angle relation, like 57, 33. So I will try and change, but change one of them, not both. Otherwise, again, you will get the same thing. Change one of the angles. Change one of the angles. And then we can sort it out, like we got cosec square theta minus cot square theta, which became 1. Then we got sin 46 into cosec 46, which again became 1, because cosec is the reciprocal of sine. So cosec 46 was written as 1 upon sin 46, and minus 1 minus 3 became minus 4. 1 plus 1 became 2, 2 minus 4 is minus 2. So we got the answer as minus 2. Now let us see the next question. Let's see question number here. Again, this seems to be complementary angles. If you see 2070 in 1020 cosec 70, then cot 20 sec 70, again 70 plus 20 will be 90. Then here 1015 and 1075, 75 plus 15 again are complementary angle. So we are going to correlate them with complementary angle. Like I'll write 1090 minus 70. Let's write it to be 1090 minus 70 upon, what is it? Cosec 70. Cosec 70 to the power 2 plus again it is cot 20, so I can write as cot 90 minus 70 upon sec 70 whole square plus 2 10 15, again I can write it as 10 90 minus 75, and 1045 is 1. We know value of 1045 is standard value 1, and 1075. Now let us solve in the next line. What happens? 1090 minus theta will be 1090 minus theta will be cot theta. 1090 minus theta will be cot 70. It is cosec 70 whole square. Cot 90 minus theta will be 10 theta. It will be 1070. It will be 1070 upon sec 70 whole square plus 2 cot 75 into 1 into 1075. Now cot 70, cot is what? Cot is cos upon sine. It is cos upon sine, and it is 1 upon sine. Cos theta upon sine theta, cos 70 upon sine 70, and divided by 1 upon sine 70, so sine 70 will come here, whole square. 10 will become sine 70 upon cos 70, and this will become 1 upon cos 70, so cos 70 will go up, whole square, plus 2 1 upon 1075 into 1 into 1075. So 1075 is cancelled. Now here what will happen? Sine 70 will cancel. Cos 70 will cancel. What will you get? Cos square 70 plus sine square 70 plus 2. Because 1075 cancel, 2 into 1 is 2. And cos theta plus sine, cos square theta plus sine square theta is 1. So 1 plus 2 is 3. The value of this will be 3. The value of this will be 3. What we did was we converted into the same angle, because when we can convert into the same angle, if they're not cutting with each other, then we can find certain relation. Like what I wrote as cos upon sine, cosec as I wrote 1 upon sine. So sine will cancel, cos remains. Here 1070 I converted as sine theta upon cos theta, sec theta is 1 upon cos theta. Again cos will cancel, sine will remain. So cos square theta plus sine square theta, finally because they are of the same angles, it will give us to be 1. Cos square theta plus sine square theta will give me 1. And plus 2. So 1 plus 2 is 3. So we got the answer as 3. Now let us see the next question. Now let's continue further into this chapter. After discussing all the 6 trigonometric ratios, or T ratios as we would call them, now we are going to discuss the reciprocal relations, which I have already actually have spoken about it, but let's talk about it again. Quotient relation. Now let us see sine theta. Let me take a triangle. Let me take a triangle A, B, C. For example, this is 90 and this angle is theta. This angle is theta. In the when I'm going to say sine theta, that means I'm taking theta as the reference angle. If I'm taking theta as the reference angle, then this becomes the base, or it is also called adjacent side. It is called base or adjacent side. This is called perpendicular, or it is also called opposite side. It is called opposite side. And of course this is hypotenuse. This is hypotenuse. This is hypotenuse. So I have to calculate, suppose sine theta. Sine theta is what? Perpendicular upon hypotenuse. Pandit Badri Prasad, or some people have, some is sine, people upon have, people is perpendicular, H represent hypotenuse, so perpendicular upon hypotenuse. So in this particular case it is BC upon AC. BC upon AC, opposite upon hypotenuse. Again I'll write for your benefit, Soka Toa. Sine is opposite upon hypotenuse. Opposite upon hypotenuse. Opposite here is BC, hypotenuse is AC. Now if I want to calculate cosec theta, cosec theta is 1 upon sine theta. Cosec theta is 1 upon sine theta. That is why they are called reciprocal relation. That is why they are called reciprocal relation. And it will become what? AC upon BC. AC upon BC. Cosec theta I used as AC upon BC. It was BC upon AC. It is AC upon BC. If you see sine and cosine, sine and cosec, not cosine. Sine and cosec are reciprocal of each other. A cosec is given, I can find sine by finding the reciprocal, 1 upon cosec. Or if cosec is given, I can find sine. If sine is given, I can find cosec. This sine, so sine theta is 1 upon cosec theta. This is one of the reciprocal relation. Sine theta is equal to 1 upon cosec theta is one of the reciprocal relation. Now let us see cos theta. Cos theta is adjacent upon hypotenuse, base upon hypotenuse. That is AB upon AC. And sec theta is just the opposite, 1 upon cos theta. So it will become AC upon AB. So this is another reciprocal relation, that is cos theta is 1 upon sec theta. Cos theta is 1 upon sec theta. Cos theta is 1 upon sec theta. Sin theta is 1 upon cosec theta, or cosec theta is 1 upon sin theta, one and the same thing. It can be, cosec can be taken up, sine can be brought down. Similarly here cos is, sec is 1 upon cos theta, or cos theta I can bring, it will become 1 upon sec theta. So sec and cosec are reciprocal of each other, sine and cosec are reciprocal of each other. Similarly when we talk of tan theta is TOA, opposite upon adjacent, BC upon AB. And cot theta, which is normally is cotangent theta, but we always are going to write as cot theta, not as cotangent theta every time. So cot theta is going to be a 1 upon tan theta, and that will be what? AB upon BC. So this relation will become tan theta is equal to 1 upon cot theta. These are called reciprocal relation. They are called reciprocal relation. That's what I had written. First thing, reciprocal relations we are going to discuss. These are called reciprocal relation. Please understand, sine theta is perpendicular upon hypotenuse or opposite upon hypotenuse, whichever, you choose one thing, Pandit Badri Prasad upon hyperbole or Sokatoa, whichever you want to choose. Or some people have curly brown hair through proper brushing, whichever is convenient to you, use that. I generally like to use perpendicular base and hypotenuse. So we are saying sine theta is perpendicular upon hypotenuse, so it is BC upon AC. BC upon AC. Cosec is the opposite of sine. Cosec is the opposite of sine. Cosec is 1 upon sine theta. So cosec theta will be reversing. The numerator will come down and denominator will go up. That is AC upon BC. It will become AC upon BC. Similarly, so sine theta is 1 upon cosec theta. Sine theta is 1 upon cosec theta. Similarly, cos theta is what? Cos theta is base upon hypotenuse. Cos theta is base upon hypotenuse. AB upon AC. It is AB upon AC. And sec is the reciprocal of cos. So sec is 1 upon cos theta. So whatever the cos theta's value is there, let us find the reciprocal of that. That becomes, it was base upon hypotenuse, so it becomes hypotenuse upon base. So cos theta is 1 upon sec theta. Similarly, tan theta is perpendicular upon base. Tan theta is perpendicular upon base. Tan theta is perpendicular upon base. So cot theta will become 1 upon tan theta or AB upon BC. So tan theta will be 1 upon cot theta. Let me write them, all the reciprocal relations together now. After explaining it to you, let me write them together. Then we discuss the next relations, which are called quotient relation. Like I would say, sine theta is 1 upon cosec theta, or cosec theta is 1 upon sine theta. It is one and the same thing. I have taken cosec here and brought sine. That you know, in ratios we can do that. Then I have cos theta as 1 upon sec theta, or sec theta can be 1 upon cos theta. Then I have tan theta as 1 upon cot theta, or that will imply cot theta is 1 upon tan theta. These are called reciprocal relations. They are related to each other reciprocally. They are related to each other reciprocally. Now let us look into the quotient relation. What are quotient relation? Tan theta, if I look at tan theta here, what is this? Perpendicular upon base. Perpendicular upon base. It is perpendicular upon base. Tan theta is perpendicular upon base. Tan theta is opposite upon adjacent. Opposite is perpendicular, adjacent is base. So perpendicular upon base. Let us divide both numerator and denominator by hypotenuse. It will become perpendicular upon hypotenuse. It will become base upon hypotenuse. Perpendicular upon hypotenuse, base upon hypotenuse. It becomes perpendicular upon hypotenuse, base upon hypotenuse. I have divided both sides by hypotenuse, so it's not going to change anything, because numerator as well as denominator is divided by the same thing, so it should not change anything. Now perpendicular upon hypotenuse is sine theta. You know, sine theta is opposite upon hypotenuse, and this is cos theta. So tan theta is always written as sine theta upon cos theta. Tan theta is always written as sine theta upon cos theta. Tan theta is sine theta upon cos theta. Tan theta can always be expressed in terms of sine theta and cos theta. If you divide the value of sine theta by cos theta, you will get the value of tan theta. That otherwise also you can see. And similarly, cot theta, as we have already said, is 1 upon tan theta. So it will be cos theta upon sin theta. Cos theta upon sin theta. This is also one of the basic principles or principal formulas which we will be using too often in trigonometry wherever till you study this T ratios or anything related with trigonometry. You will be always coming across these, whether in MSc or whether you're doing in post-graduation or graduation or in 10th or 9th. These things will be used everywhere. It doesn't change. Or whether you are in GTS, which name has changed now. It is not Great Trigonometrical Survey. It is only Survey of India, which is situated in Dehradun. And the house of Sir George Everest is in Missouri in a very dilapidated condition. So cot theta is 1 upon tan theta, cos theta upon sin theta. Let me write them down also on one side. And then we will discuss certain more things. Okay, let's rub it off. You must have noted it down, I'm sure. Now let us talk about fundamental identities. Fundamental identities. We are going to use I'm going to prove them and I'll show them so that you never forget that. I'm sure either through Sokatoa or some people have curly brown hair through proper brushing, or Pandit Badri Prasad upon Har Bol, you will never forget if you learn that method to remember the T ratio. There's no question of forgetting them. There's no question of forgetting them. You can remember a name, Pandit Badri Prasad upon Har Bol, sin theta, cos theta, tan theta, or some people have curly brown hair through proper brushing, or Soka Toa. Whatever you want to do, whichever method suits you, you use that. It is no hard and fast rule that you must follow that. Whichever suits you, whichever you feel comfortable with, you please use that. Now let me do some fundamental identities. And for fundamental identities, I'll start with very fundamental theorem, which is Pythagoras Theorem. In a right angle triangle, the square described on the hypotenuse is equal to the sum of the square described on the remaining two sides. In this right angle triangle, AC square is equal to AB square plus BC square. This is Pythagoras theorem. This is Pythagoras theorem. In a right angle triangle, the square described in the hypotenuse is equal to the sum of the square described on the remaining two sides. So this is Pythagoras theorem. Now, I'll tell you what basically I'm going to do so that you understand what I'm doing. What I'll do is, first I will divide the whole equation, this Pythagoras theorem, with AC square, that is hypotenuse square. Then I'll divide the whole equation by AB square, and then I'll divide at last the whole equation by BC square. Once by hypotenuse square, then by perpendicular square, then by hypotenuse square. And from that, I'll get three basic identities which we will be using throughout our study of this chapter. Now, if I divide it, AC square, divide the equation, divide it by AC square. Let me divide it by AC square. So AC square upon AC whole square. This will become AB upon AC whole square. And it will become BC upon AC whole square. This will become 1 square. 1 square is 1. AB upon AC. I am taking reference angle as theta. AB is what? Base. AB is base. And this AC is AC is hypotenuse. So base upon hypotenuse whole square. and this is BC. BC is perpendicular upon hypotenuse, whole square. So B upon H is what? It will become cos theta whole square, and it will become sin theta whole square. Or I can write sin square theta plus cos square theta is equal to 1. This is one of the basic identities. So we did arrive at sin square theta plus cos square theta is equal to 1. What did we do? We wrote Pythagoras Theorem, that is, the square described a hypotenuse. In a right angle triangle, the square described on hypotenuse is equal to the sum of the square described on the remaining two sides, AB square plus BC square. Then what I did was, I divided the complete equation, this complete Pythagoras Theorem statement, by AC square, which was hypotenuse. I divided the complete statement of the Pythagoras Theorem, which was written mathematically, by AC square. When I divided AC by AC square, I got 1. Then I got AB upon AC whole square, and I got BC upon AC whole square. Then we looked for what is AB, what is AC. AC we know is hypotenuse. So hypotenuse. AB is, when we are talking of theta as the reference angle, AB is the base. So base upon hypotenuse square. And BC is perpendicular when theta is the reference angle. So it became cos square theta plus sin square theta. So we can write it as, we always write it as sin square theta plus cos square theta is 1. This is one of the fundamental identities which we will be using every time. Whenever you will see sin square theta plus cos square theta, you will have one thing in the mind, that I can write it equal to 1. Or sometime if you see 1 and you need sin square theta plus cos square theta, I can replace 1 by sin square theta plus cos square theta. So this is one of the identities which I am going to write separately, and remove this because I am going to do the next one now. So we calculated one of the identities as sin square theta plus cos square theta is equal to 1. We wrote 1. First identity is sin square theta plus cos square theta is 1. Now what I am going to do is, we divided by AC. Now let me divide the whole equation by AB. We divided by AC, now I am dividing by AB. In the next case I am divided by BC, and see what happens. When you divide AC by AB whole square is equal to AB upon AB whole square, obviously this will become 1, plus BC upon AB whole square. Now we will replace AC, AB and BC by the appropriate side. AC is hypotenuse, so wherever AC is there, it is hypotenuse. Now AB is what? We have divided by AB, by base. We have divided by base. So hypotenuse upon base whole square is equal to 1, plus BC is what? Perpendicular upon base whole square. Now base upon hypotenuse is cos theta. Base upon hypotenuse is cos theta. If you see, base upon hypotenuse will be cos theta. If you write Pandit Badri Prasad upon her board, then you will see that cos theta is base upon hypotenuse. Second one is base upon hypotenuse, which is cos theta. Opposite of this is hypotenuse upon base. Opposite of cos is sec. So sec square theta, because it is a square, so sec square theta is equal to 1, plus perpendicular upon base is 10 square theta. It becomes 10 square theta. So generally we write it as sec square theta minus 10 square theta is always equal to 1. Because I'm trying to convert everything on the right side as 1. Sec square theta minus tan square theta is equal to 1. But I'll show you later on what we all can do with this. Second one is sec square theta minus tan square theta is 1. And there is nothing to remember in it or mug it up. There's nothing to mug it up. I wrote Pythagoras Theorem, then I divided first by AC, then I've divided by AB, and then I'll divide it by BC now. And I've got two relations already. Sin square theta plus cos square theta is equal to 1. I have got sec square theta minus tan square theta as 1. Now let me take the third relation. And instead of dividing by AB, let me divide it by BC. Let me divide it by BC. When I divide it by BC, we are one by one we are taking all the three sides, which are perpendicular base and hypotenuse. Let us divide it by BC. AC upon BC whole square is equal to AB upon BC whole square plus BC upon BC whole square. We divided the complete statement of Pythagoras Theorem, mathematical statement of Pythagoras Theorem by BC's. When we divide it by BC, actually BC is square actually, not BC, BC square. We are in the earlier also we divided by AC square, then AB square. Correct it in that also. I just wrote BC, it should be square of that. So AC upon BC whole square, AB upon BC whole square, plus BC upon BC whole square. In the first two also please write down AC square and AB square. Correct it where I have written that. I have just written by AC, it should be AC square, and I have written AB, it should be AB square, like we are writing by BC square. Now AC upon BC, what is AC? AC is hypotenuse and BC is perpendicular. Hypotenuse upon perpendicular whole square. AB is base and BC is perpendicular whole square plus 1. BC square upon BC square is 1. BC square upon BC square is 1. Now hypotenuse, perpendicular upon hypotenuse is sine theta. Opposite of sine is cosec theta. It is cosec square theta. Perpendicular upon base is tan theta. It is opposite of tan theta, which is cot theta, cot square theta. It is cot square theta is equal to 1. Again I will write it as cosec square theta minus cot square theta is equal to 1. What I am trying to do is, in these all basic identities, I want right hand side to be 1 for your memory. There has to be for memory. Cosec square theta minus cot square theta is equal to 1. Now all the three identities are there with you. All the three identities are there with you, and these three identities can be written in different form depending upon the situation or the question, where what do I want? According to the question I can change it. Now let us see what do I want to change and what do I want to show you. It's just question of changing the subject of formula. Like if you have, the first statement is sin square theta plus cos square theta is equal to 1. Suppose I want to write sin square theta in terms of cos square theta. So I can write this as sin square theta is equal to 1 minus cos square theta. I shifted cos square theta to that side. Or if I want to calculate cos square theta, then I can write cos square theta is equal to 1 minus sin square theta. So from one formula, sin square theta plus cos square theta is equal to 1. From one identity, I have three relations, depending upon what is the subject of formula which I am going to calculate. Where it depends upon the question to question. What kind of a question have you got and what do you want? So sin square theta plus cos square theta is 1, or sin square theta is 1 minus cos square theta, or cos square theta is 1 minus sin square theta. Similarly, second one is sec square theta minus tan square theta is 1. It can be written as sec square theta as 1 plus tan square theta. Or tan square theta can be written as sec square theta minus 1. So whatever you want sec square theta minus tan square theta together, you want sec square theta in terms of tan square theta, or you want tan square theta in terms of sec square theta, depends upon you what you want. Or what is the necessity of applying it to a question. It depends upon the question, what are we looking into the question. Next is cosec square theta minus cot square theta is equal to 1. Cosec square theta minus cot square theta is equal to 1. So I can write it as cosec square theta as 1 plus cot square theta. Or I can write cot square theta as cosec square theta minus 1. It is just this change of subjective formula. Here I have made cot square theta subjective formula. Here cosec square theta is the subjective formula. Here sec square theta is subjective formula. Here tan square theta is the subjective formula. Here sin square theta is there. Here cos square theta is there. Basically, the three formulas are there which are written here. Sin square theta plus cos square theta is 1. Sec square theta minus tan square theta is 1. And cosec square theta minus cot square theta is 1. So basically, these are three fundamental identities. And then we can get more relations out of these identities. More relations from these identities. That is all we have to do.